section, we're going to look at the sum and difference formulas and how they can be used. So in this box, if we have the sine of u plus v, that is equal to the sine of u cosine of v plus the cosine of u sine of v. So do you notice that it's not just distributive property? Like a lot of people would think that it's the sine of u plus the sine of v is what the sine of u plus v equals. But that's incorrect. So this is what it actually equals. And you have the sum or you have the difference formulas. So here is the difference formula for sine. And you notice for sine, you get a sine and cosine, and the minus and the minus will be the same, or the plus and the plus will be the same. Now, let's look at the sum and difference formulas for cosine. The sum and difference formulas for cosine is kind of interesting because you get cosine u cosine v, subtract, if this is a sum, sine u sine v. And then the difference formula is cosine u cosine v plus sine u sine v. And then tangent, here is the sum formula, and here is the difference formula. So it's tangent u plus tangent v over 1 subtract tangent u tangent v. Or if you're looking at the difference formula, it's tangent u minus tangent v over 1 plus tangent u tangent v. And I know that it seems super complicated right now, but these formulas are actually really, really easy to use. And the more that you do the homework and practice, the easier they are to actually remember. So just all of this recall part on the top is just showing you, like if I have a square root property, like the square root of 36 plus 64, that's the square root of 100, which equals 10. And you notice it's not the same thing as the square root of 36 plus the square root of 64, which happens to be 14. So this is the wrong one. So same thing down here is just making a comparison of the sum and difference formulas. All right, so be careful with the plus and minus signs. And let me show you then how you can use these multiple different ways. So the first thing that we're going to do is show you how you can write this expression as the sine of an angle. So just the sine of a single angle, and then we can give the actual exact value. So this one is just helping us recognize the property. So do you notice that we have the sine of u cosine of v subtract the cosine of u sine of v. So looking up here, you can see that we are looking at the difference formula, this second one. Maybe I should erase these and then I can highlight it. So we're looking at this formula here is what this is right here. All right, so what we're going to do then is we're just going to rewrite it as the sine of u subtract v. So the sine, and again, here's our u, here's our v, here's our u, here's our v. So this would be the sine of pi over 4 subtract pi over 12. Now we can go ahead and subtract that by getting common denominators. So the common denominator is 12. And then I have 3 pi over 12, subtract 1 pi over 12 is equal to 2 pi over 12. So this is the sine of 2 pi over 12. And 2/12 reduces to pi over 6. So this is the sine of pi over 6. Let me write that a better way. Sorry. Let's fix that. So the sine of pi over 6. So now we can evaluate what's the sine of pi over 6. The sine of pi over 6 is 1/2. So I was able to use this trig identity to write it as a single angle and then give the exact value. So let's do the same thing. This time we're going to be looking at degrees, and I want to find the exact value of the cosine of 195 degrees. Now 195 degrees is not special. Special, we would be looking for reference angles, and reference angles would have to be 30 degrees, 45 degrees, or 60 degrees. So looking at example 2, I have find the value of the cosine of 195 degrees. Now, 195 degrees is not special, so I don't know what that is without a calculator, but I can rewrite it. So we know that 195 degrees is 150 plus 45. And 150 is special because it has a reference angle of 30 degrees, and 45 degrees is special. So cosine of 195 is equal to the cosine of 150 plus 45 degrees. Now what we're going to do is take that value and we're going to write it as a sum of cosine. So it's cosine u, cosine v. The 150 is the u and the 45 is the v. So I have cosine u, cosine v, and that's going to be cosine of 150, and then cosine of 45 degrees, subtract, and then I've got the sine of u, so the sine of 150, times the sine of v, so the sine of 45 degrees. You know what the cosine of 150 is. It has a reference angle of 30 degrees, and so the cosine of 30 degrees is root 3 over 2. But I'm in the second quadrant, so where am I? I'm in the second, which is going to make this a negative root 3 over 2. The cosine of 45 is root 2 over 2. So we're going to multiply those together, subtract. The sine of 150 has a reference angle of 30 degrees, so that's 1/2. And it's going to stay positive because we're in the second. All students, sine is positive, student sine. And the sine of 45 is root 2 over 2. So now what we're going to do is just go ahead and simplify this, and we will have our answer. So when we multiply these fractions, root 3 times root 2 is root 6. So this would be negative root 6 over 4. Subtract root 2 over 4. And this is going to be common denominator of 4, and we have negative root 6 subtract root 2. And there's my final answer. Let me highlight it. All right, let's look at the next problem. Example 3, we're going to use the sum identity for tangent, and the sum identity for tangent is tangent u plus v is equal to tangent u plus tangent v divided by 1 minus tangent u tangent v. So you can see that this has that same setup. The u is the 80 degrees and the v is the 55 degrees. 1 subtract tangent of 80 and then tangent of 55 degrees. So I can take this and rewrite it as the tangent of u plus v using the sum identity. So I will have the tangent, and u is 80 and v is 55 degrees. And so now you can go ahead and add 80 plus 55. So this is the tangent of 135 degrees and the tangent of 135. Again, where are you? You're in the second quadrant, so we know it's negative. What's the reference angle? It's 45 degrees, and the tangent of 45 degrees is 1. So my answer is negative 1. Okay, looking at example 4. It says find cosine u minus v. And I'm going to give you what cosine u is. cosine u is negative 15 over 17, and that's in the pi used between pi and 3 pi over 2. So this is telling me I'm in quadrant 3 for angle u. And then sine v is 4 over 5, and that's between 0 and pi over 2, which means I am in quadrant 1. So looking at this, I drew a drawing, and we know that cosine, when I look at cosine u is equal to negative 15 over 17, cosine is ca, which is adjacent over hypotenuse. So you see how here's angle u, and then I drew a line up to the x-axis, and I formed this right triangle. And this is the adjacent side, which is the 15, and this is the hypotenuse side. Now, triangles have positive sides, but sine, cosine, tangents are positive, negative. And cosine is negative in the third quadrant. So anytime you go left, let's make this a negative 15. Anytime you move down, we're also going to make that a negative. And this is a special right triangle, which is 8, 15, 17. So that's going to give you 8 right there. All right, and then I have sine V is in the first quadrant. So here's angle V. And sine V equals 4 over 5. Sine is so, which is opposite over, ooh, I almost put adjacent. That's tangent. Opposite over hypotenuse. So here's the opposite side. Here's the hypotenuse side. And this side is going to be the adjacent side, which is going to happen to be 3, because this is a 3, 4, 5 triangle, and I'm going to have all the sides positive because I'm in the first quadrant. So now what we're going to do is we're going to use the Pythagorean Theorem. We did the Pythagorean Theorem to find all the missing sides, and then what we're going to do is we are going to figure out the difference, cosine of u minus v. So I'm looking for the cosine of u minus v. So looking at this, the cosine of u minus v is the cosine of u, cosine of v, plus the sine of u, sine of v. So cosine of u, here's the cosine of u, and if I come up to angle u, cosine is ca, which is adjacent over hypotenuse. So the cosine of u is negative 15 over 17. I'm going to multiply that by the cosine of v. The cosine of v, here's v, is ca, which is adjacent over hypotenuse. So that's 3 over 5. I'm going to add that to the sine of u. Here's u, and the sine is so, opposite over hypotenuse. So negative 8 over 17. And the sine of v, so over to triangle v, so opposite over hypotenuse, is 4 over 5. In quadrant 3, just note that the sign is negative. So the sine of u ended up being a negative 8 over 17. And in quadrant 1, the cosine is positive. So the cosine of v ended up being 3 over 5. So then you'll just take this and simplify it with some algebra. 17 times 5 is 85, and negative 15 times 3 is negative 45. So I have negative 45 over 85. Subtract, and then negative 8 times 4 is 32 over 85. And so calculator, 45 and 32. I probably should be able to do that without a calculator. 77, yeah, some of you guys probably got that by the time I stuck it in the calculator. So this is negative 77 over 85, and there's your solution. So here I'm going to show you how you can prove your identities, making the left side match up with the right side. You notice the left side of example 5 is far more complicated than the right side. So we're going to start with the left side. And if you notice, this, I have sine alpha plus beta. And so right here is the formula for sine alpha plus beta, or the identity. So the sine of alpha plus beta is going to give me the sine of alpha, the cosine of beta, plus the cosine of alpha, and then the sine of beta. And that's all divided by the cosine of alpha, cosine of beta. Now, in the numerator, do you notice that we can factor out a, let's see. Actually, we can't factor out anything. So we're going to take this and we're going to split this fraction up. So here's your denominator, and we're going to have a common denominator. So here's my common denominator of cosine alpha, cosine beta, plus common denominator, cosine alpha, cosine beta. And then we're going to split the numerator. So this numerator is going to split into two parts. You have sine alpha, cosine beta, and cosine alpha, sine beta. And again, what am I doing? I'm trying to make this look like tangent alpha plus tangent beta. Now you can see that the cosines are going to cancel here, and over here we have the cosines cancel. And so now I have sine alpha over cosine alpha. Well, that's tangent. So that's tangent alpha plus, and I have sine beta over cosine beta. Well, that's tangent beta. And that's using the quotient identities. And what does that equal? It equals tangent alpha plus tangent beta. And I want you guys to notice that these two sides are now equal, and you always only work one side of the proof. So this is like geometry proofs, where you're trying to get one side to match the other side when you are verifying identities. So I'm no longer solving here, I'm just verifying the identity. All right, last one is the you try. And if you'll go ahead, because it's you try, you're going to try this one all on your own. And what you're going to do is you're going to take sine pi over 2 subtract theta, and you're going to show me how come it is equal to cosine theta. So look at the identity. You're looking at the difference identity, and see if you can make this work. Good luck. And last thing is, in ALEKS, instead of just verifying identities, you may use these identities to actually solve. So I may give you a couple of problems where here are the identities, right? And you're going to use those to help you solve a trig equation.